right, welcome to Lesson 5. In Lesson 2, you learned about how to graph these, right? Well, now we're going to graph them and see if we can find out any facts about what we have. Okay, so remember we said if it's in this form, which is called standard form, we could pick any x or y, it doesn't matter. Okay, so I'm going to do that. I'm going to pick numbers for x and then solve for y, or numbers for y, solve for x. I need at least 3 points, 1 for insurance. So let's say I pick, I don't know, let's say I pick 0 for x. Okay, I could do that, and then I would get an intercept, wouldn't I? I would get the y-intercept. Okay, so x minus y equals 4. If I have 0 for x, I have minus y equals 4, negative y equals 4, divide by negative 1, divide by negative 1, y is negative 4. So I would have 0, negative 4, okay? I could also pick 0 for y. If I pick 0 for y, I'm going to erase this because I really need to keep that on the board. If I pick 0 for y, I bet you I can almost do this one in my head, but I won't. If I pick 0 for y, I then have x minus 0 equals 4. That's just x equals 4. I love these zeros. I love getting the intercepts. Most of the time, they're really easy. Now, I want one more point just for insurance, okay? Let's say we pick, I don't know, 3 for x, okay? I could have picked a y. Doesn't matter. Okay, I could have picked all x's. I could pick all y's. It doesn't matter. Okay, but if I pick 3 for x, I get 3 minus y equals 4. Subtract 3, subtract 3. I get negative y equals 1. And then I divide by negative 1, divide by negative 1, y equals negative 1. So I get 3, negative 1. So there are my 3 points. 0, negative 4, 4, 0, 3, negative 1. I'm going to actually come over here and graph that. Okay, 0, negative 4, right here. Okay, 4, 0, right here. And if we're right, this next point will be collinear with these points, 3, negative 1, and there it is. Yes, collinear. I'm going to take my handy-dandy ruler now, and I'm going to connect these points. Okay. That's not bad. Make a line bigger than your points, okay? Make sure they have arrows because I can pick as many points as I want. And remember what this represents? It represents all the solutions, and there's infinitely many solutions to this equation. Now, I know I want you to graph this, and then I want you to find the slope of each and draw a conclusion. But before I do that, because I'm going to run out of space, I'm going to do it in a little different order. I'm going to find the slope of this line right now. Okay, so we know 2 ways right now to find slope. One way is to count if we have the graph. The other way is to use that slope formula we talked about the other day, which is m equals y2 minus y1 over x2 minus x1. Well, I could do that, but why shouldn't I count? I'm going to count right now. So let's take 2 points on this line, any 2 points, and I'm going to count. Now notice, kind of be a little bit smart about what kind of sign your slope should have. Remember, from left to right, this line is going up, so it should be a positive slope. So if you get a negative slope, you're wrong. All right? So let's take a look at this. I could take any 2 points. How about these 2? This one and this one? I could take this one and this one. Doesn't matter. Okay? I'm going to go up 1. That's a positive 1. And then 1 to the right. That's a positive 1. So it's 1 over 1, or the slope is 1. So we know the slope of this line is 1. Okay. So let me write that down. I don't really need this anymore. Slope is 1. Okay. The other thing that I'm supposed to do is I'm supposed to solve this for y in terms of x. So let me do that. We learned how to do that in literal equations. So we're going to solve this for y. So I'm going to subtract x, and I get negative y equals negative 1x plus 4. I don't need the negative 1, but I might want to write it. Okay, just so you can see what's going on. I divide by negative 1 to solve for y. I divide by negative 1 to solve for y. Divide by negative 1 to solve for y. And I get y equals, divide by negative 1, we get x, divide by negative 1, minus 4. So that's my equation solved for y in terms of x. Okay? Now, let's talk about some intercepts here, possibly. All right. Let's talk about the x-intercept and a y-intercept while we have this here. The x-intercept is 4, or 4, 0. Okay? Let me make sure you understand that and why it's that way. Just erase part of that line. It's really okay. Okay? Oh, straight as an arrow. Okay, the x-intercept is 4, or 4, 0. The y-intercept is -4, or 0, -4. Let me just write that down. That was the 4, right? Yep. 4, 0. The y-intercept. This is extra, by the way. Freebie. Freebie. Didn't ask me to do that. Just thought I would since we just got off of intercepts a couple of sections ago. Okay, so that's what I know from this line. Okay, and I have infinitely many points on that line. All right, let's do B. Here we go. Y equals -3x plus 5. This one is already solved for y, so we don't have to solve. That's why it doesn't say solve for y in terms of x, because it already is. Whenever we graph, we can just make a chart. Okay. Remember we talked about in lesson 2 that when it's solved for one of the variables, like y here, like it is for y, then it's easy to pick x's. Okay. I'm gonna pick some x's. 1, 2, 3. I got to be honest. I pick those. I usually like to pick a -0 and a positive, but to be honest, they won't fit on my graph. Okay. Here we go. Let's look at 1. -3 times 1 is -3. -3 plus 5 is 2. -3 times 2 is -6. -6 plus 5 is -1. -3 times 3 is -9. -9 plus 5 is 4. That was really pretty simple. Okay, let's graph these, all right, and see what we got. 1, 2. 1, 2 is right here. All right. 2, -1. 2, -1 right here. And 3, 4. That can't be right, so I obviously made a mistake. Let's do it again. Yep, because it's negative. See, that's how you check. That's why you want an insurance point. So that's -3 times 3 is -9. -9 plus 5 is -4. That's exactly why you want an insurance point. I made that error on purpose. No, I didn't. But that's why you want an insurance point, because no way could it have gone back up. Okay, so that's 3, -4. Okay, so there you go. Now you're collinear. Now I know I'm right. Okay, let's put the line up here. Make sure you don't put the line actually on your ruler. Look, I've done that. Okay, here we go. Oh, perfect. Didn't even get it a straight line with a ruler, but that's all good. All right, so let's take a look now at our slope of this line. All right, I'm going to count like I did before. I can take any 2 points. Notice that this is going to be a negative slope because it goes down from left to right. So here we go. Maybe I'll take these 2 points, this one and this one. Okay, let's say I start here. Well, that would be 1, 2, 3, up 3. To the left 1. To the left 1 is a -1. So it's a +3 divided by a -1 makes this a -3 slope. So slope is -3. And let's get some intercepts going on here. X-intercept. Okay. X-intercept is actually somewhere between 1 and 2, so I can guesstimate. Okay, now listen to me for a minute. If I really want to know what that is, this is really important. It's right here. If I really want to know what that is, what could I do? We're going to talk about that. Let's get the y first. This is really important. The y is important. The y-intercept is 5. Okay, let's talk about when it's in the middle, what I do. It's going to happen a lot. Well, if the x or y-intercept is in the middle and I can't see what it is, I could actually just solve for it. The x-intercept occurs when y is 0. So if I made y 0, I could find the x-intercept. Okay? The x-intercept, y would be 0. Add 3x. 3x equals 5. Divide by 3, we get 5/3 or 1 2/3. So the x-intercept, if you care, is 1 2/3. Okay? 1 2/3. So you should know that if you can't see it graphically, you can always get it algebraically. Okay? All right. Now, it says, find the slope of each line, and can you draw any conclusions from what you just did? Okay. Let's see if we can. Let's take a look at what we have here. Let's erase this. Let me highlight this in red. This is my equation to solve for y. This is my equation solve for y. Now remember, this stuff, the x-intercept, y-intercept, that was a gimme, that was an extra. Okay? So I'm looking at what I just did, which was graph this and find the slope. So I'm looking at the slopes, and I'm looking at what's in red there circled. Do you notice anything? Well, if you did notice something, what you should notice is that the slope of the line is the coefficient of x when the equation is solved for y. So here's a 1, so that's 1 right there. So when the equation is solved for y, you have the slope of the line. Same thing here. The slope of the line is, when you solve the equation for y, you'll have the slope, it's the coefficient of x. So anytime you have an equation, let's say -4/3 x plus 2, if the equation is solved for y, you have the slope. The slope is -4/3, okay, for this problem. So that's what we know about slope. So now we have 3 ways to find slope. The 3 ways are, one is you can count if you have a graph like we just did. The second thing is what we did yesterday, which is that we use the slope formula, m equals y2 minus y1 over x2 minus x1. And the third way is that if we have our equation solved for y, the slope, oh, hold on here. Oh, that's positive 1. Okay, no, that's right. Okay, I thought I made a mistake on the board. That's good. Okay, and the third way is when I have the equation solved for y, the slope is what is connected to the x, the coefficient of x, okay, when the equation is solved for y, okay? And that takes care of that. So that's the third way to find slope. Okay, let's take a look at this for one other second. Before I wrote the x-intercept here as 1 2/3, remember that could be written as 1 2/3 or 1 2/3, comma 0. Because remember that we know y is 0. Same thing here. We can write this y-intercept as 5 or 0, 5. So here I could write the x-intercept as 4, 0 or just plain 4. And the y-intercept as 0, -4 or just plain -4. Now, I want you to notice some other thing. There's a reason that I gave you that freebie of the x-intercept and the y-intercept. We already said that the coefficient of, once you're solved for y, once your equation is solved for y, we already said that the coefficient of x was the slope. But this constant number also gives me something. Okay, do you see what the constant number gives you? Okay, the constant number is the, look, the constant here is -4. That is the y-intercept. The constant number here is 5. That is the y-intercept. So we have something called standard form, which we talked about before, and I'll talk more about that in a second. And we have slope-intercept form of a line. Slope-intercept form of a line is y equals mx plus b, where that means if your equation is solved for y, okay, if your equation is solved for y, m is the slope, and guess what b stands for? B stands for the y-intercept. So you get 2 pieces of information from this form of the line, y equals mx plus b. You get the slope, you get the y-intercept. In this form, you get no pieces of information that we can readily use by just looking at the equation. So this form is a lot nicer form when we want different pieces of information, the slope and the y-intercept. So if somebody tells me I have an equation, 7x minus 2, I know my slope is 7. My y-intercept is -2 because it's solved for y. But the important thing here, you have to understand, it's got to be solved for y. Okay, let's take a look at what we mean. We want to find the slope of each line. And you know I'm going to give you a freebie and get you the y-intercept too, but we want the slope. First thing we can do is say, well, if I have an equation of a line, the easiest way to find the slope of a line given the equation is just to solve the equation for y. This is already solved for y, so all I have to do is look for the coefficient of x. This is the slope, okay? So the slope is -3/4. The slope is -3/4. That's what I know. And this is a freebie for you. The y-intercept is 1. Okay, that's a freebie. But how do I know it's 1? Because it's the constant term. So that's how I find the slope and the y-intercept. In this equation, It is not solved for y. That is not the slope. Negative 2 will not be the slope. Okay? We have to solve this for y first. We know how to do that because we've solved literal equations before, and I have no idea what lesson, to be quite honest. But we've done that. So we add 2x. We add 2x. Might have been chapter, I don't know, what one. Whatever. Okay. 5y equals 2x plus 3. Okay, still not solved for y. Okay, that coefficient of y has to be a 1. We have to solve it for y. So we divide by 5, divide by 5, divide by 5. Y equals 2/5 x plus 3/5. Okay, now you're solved for y. Once I'm solved for y, I have the slope is the coefficient of x. So the slope is 2/5. Remember the symbol for slope is m. Okay, the y-intercept, here's a freebie. The y-intercept is 1. Y-intercept is 3/5. 1, that's the other problem. Y-intercept is 3/5. Once you solve it for y. Notice, 2/5, that wasn't the coefficient of x before. We must solve this for y. And the coefficient of x is the slope, and the constant term is the y-intercept. Let's take a look at this. You thinking hard here? We have to solve this for y. There is no y. So I can't solve this for y. You know why I can't solve this for y? Because this has an undefined slope. You know why? Because this is a vertical line. Okay, and we talked about that in lesson 2, I believe. When it says x equals a number, we're going to get a vertical line. So this is a vertical line, and all vertical lines have an undefined slope. So think about it. How would I write that? Y equals mx plus b. Y equals undefined x? That makes no sense. So that's why I can't solve this for y, because it's a vertical line. Now, let's talk about the y-intercept. The y-intercept occurs when x is 0. Screw it again. The y-intercept occurs when x is 0, and x can't be 0. X has to be 4. So this has no y-intercept. If you think about what this looks like, if you think about it in your head, what this looks like, okay, think about it in your head. Vertical line at 4. 1, 2, 3, 4. Here's what it looks like. Oh, straight as an arrow. See, no y-intercept. Has an x-intercept, does not have a y-intercept. Undefined slope. That's what you got. So that's why that's going on. Pretty cool. If you think about it, if you understand all of this and how it comes together, it's like a thing of beauty. Okay? Here we go. Let's look at this. Y equals negative 2. That already is solved for y. But there is no x, so the slope is 0. Because another way to write this is y equals 0x minus 2. Okay? So the slope is 0. There is no variable. Slope is 0. You know why the slope is 0? Because this is a horizontal line. This is a horizontal line. Remember we said y equals some number was a horizontal line. Okay? Now, let's talk about the y-intercept. The y-intercept occurs when x is 0. Yes, x can be 0 as long as y is negative 2. And this is a freebie. You got this for free, because all they ask you to do is find the slope of each line. So I'm going to ask you in the next couple of problems to find the slope of the lines, of the equations of the lines that I gave you. Okay? So go to your workbook, do that, click on when you're ready. All right, let's see how you did. Here we go. Y equals negative x plus 1. That already is solved for y. No real work here. There's a negative 1 here that you don't see. So the slope is negative 1. And freebie, y-intercept is 1. Okay? Let's take a look at this. A little different. I have to actually solve this for y now. So I'm going to add x. Add x. 4y equals x plus 3. I want the constant term last. Okay, I want to divide by 4, divide by 4, divide by 4. You might want to do that. Put a 1 there. It's a little easy to write then. And see, y equals 1/4 x plus 3/4. Okay, now we're solved for y. As soon as we're solved for y, we can then pick out the slope and the y-intercept. The slope is 1/4. The y-intercept, which is the b, y-intercept is called the b, that is 3/4. Okay? Or, by the way, I haven't been saying this, but the point is 0 3/4, remember, right? Because the y-intercept occurs when x is 0. Just like the point here would be 0, 1, because the y-intercept occurs when x is 0. Don't lose sight of that, okay? Otherwise you won't know where it is on the graph. Okay, x equals -2. Again, cannot solve that for y. I cannot solve that for y because this is a vertical line. Okay, so I cannot solve that for y. It's got an undefined slope. So it's really good to know that that's a vertical line and know what the slope of a vertical line is. So the slope is undefined. Okay, and now y-intercept. Y-intercept occurs, remember, when x is 0. Yes, you're right, you can't have x being 0 here because x has to be -2, so there's no y-intercept. Awesome. Okay, let's take a look at this. We have to solve it for y. It is solved for y, but we have no x. Okay, so this is almost looks like this. Y equals 0x plus 0. That's what that really is. Y equals 0x plus 0. So the slope is 0, okay, because this, yes, is a horizontal line. The y-intercept is 0, right? Because it occurs, remember, when x, the y-intercept occurs when x is 0, and x can be 0 as long as y is 0, because y has to be 0. But it tells you right here, the y-intercept is 0. So this is the point 0, 0 for the y-intercept. And the point is 0, 0 if you care. So remember, when you have the y-intercept, x must be 0. And that's how you do those. Let's see what else we can figure out about slope. Okay, let's take a look at these two. We want to graph these on the same set of axes. We're going to graph both of these lines, and we know they're lines because from lesson 2 we learned that they're linear equations in 2 variables, okay? So we know they're going to be lines. All right, we're going to graph them both on this, and watch, I'm going to show you something that's really cool. We know we can graph by making a chart. You can always graph no matter what you graph by making a chart, but now we know a couple of other things, so watch. I know that this has a slope of 3 and has a y-intercept of 0. That means the point is 0, 0, because when y-intercept occurs when x is 0. Okay? A slope of 3 means 3 over 1. Let me explain what that really means. You know, we can count that. That means that I went up 3 to the right 1. That means to get from one point to another point, I go up 3 to the right 1. So I'm going to graph that using what we call the slope-intercept method of graphing. Do you have to do that? No. Can you use the intercept method? Yes. Could you use the just graphing regular, making a chart? Yes. You can do whatever you want, but this is just another method if you like it. I like it as long as the y-intercept isn't a fraction. It's really hard to do when the y-intercept is a fraction because then you have to count in the middle of a box, and that's hard to do. But as long as the y-intercept isn't a fraction, this is the method I use. Okay, so here we go. The point is 0, 0, so that's where we're going to start. And now, to get from one point to another point, you go up 3 to the right 1. Up 3, 1, 2, 3 to the right 1. Up 3, 1, 2, 3 to the right 1. I could even go, watch, 3 over 1 is the same thing as -3 over -1. I could even go down 3 to the left 1. Down 3, 1, 2, 3 to the left 1. Down 3 to the left 1. Down 3 to the left 1. So I could do that all day, but I think I'll stop because I'm tired. Okay, so that's it. That's my line, y equals 3x. Pretty cool. Goes through the origin. Okay, so now I'm going to draw my line. Okay, so let's do the other line that same way. Y equals 3x minus 2, because it's just really quick. Okay, slope again. 3 over 1. Yep, we know that means up 3, right 1. Okay. Y-intercept, -2. So here we go. If you want to use slope to move, you have to write it as a fraction, because remember, the top number gives you the vertical movement, the bottom number the horizontal, rise over run. Okay, so watch. I'm going to use it a different color because I'm hoping you'll see something. Okay, -2. So first I go to my y-intercept, 0, -2, and then I use the slope to move, okay? So you ready? And from here, not from there, but from here, this is the point on your graph. Up 3, 1, 2, 3, over 1. Up 3, 1, 2, 3, over 1. I could go all day. I could go down 3, remember, over 1, all day long. Okay, now, talk about that. What kind of lines do you have? If you don't know the name of these are lines that will never meet. They are called parallel lines. Parallel lines are lines in the same plane that never meet, and they are parallel lines. What's really cool about parallel lines is that they look like railroad tracks. That's why I think they're cool. Okay, now here's the deal. The deal is, why do you think they're parallel? Because you think there's anything about the equation that makes them parallel. Think about them. Think about this, that they both have the same tilt. That tells me that the lines are parallel, because if I have the same tilt, no matter which way I go, my lines will be parallel. So actually the slope is what makes them parallel. Lines with the same slope are parallel, because this has a slope of 3 and this has a slope of 3. Those lines are parallel. The y-intercepts can never be the same, because if the y-intercepts are the same, then they'd meet. So if the lines have the same slope, they are parallel. What happens if the lines have the same slope and they have the same y-intercept? Well, they'd be the same line. So I'm not talking about that case, okay? But as long as they have the same slope, okay, those lines are parallel. That's why those lines are parallel. So the slope tells me that the lines are parallel. Okay, so that's what we know about equal slopes. Let's see if we can figure out something else. All right, let's take a look at this. Tell me what you know about these lines. Think about what you know about these lines already. Well, already I know they're not parallel. How do I know they're not parallel? Because they're not equal slopes, okay? Already I know they're diagonal lines. First of all, I know they're lines. How do I know that? Because we have two variables, okay, and they're linear equations in two variables. I know they're not parallel. I also know they're not horizontal or vertical, because the slopes are not 0. So I know a lot of things already. That's important. So that when you go to graph it, you don't get something that's weird, okay? So let's take a look at this. The slope here is 2/3. The y-intercept is -5, and that's the b, remember? Okay, so that's the point 0, -5. Here, the slope is -3/2, and the y-intercept is 1. Okay, and the point I go through is 0, 1, because remember the y-intercept occurs when x is 0, and the y-intercept is the b term in y equals mx plus b. And just because it says plus b doesn't mean that has to be a plus, obviously. Okay, because if I wanted to, I could write that as plus -5. I don't want to. All right, here we go. Let's graph that first one. All right, 0, -5, that's right here. And a slope of 2/3. That means up to and to the right 3. Up to, from where I am, up to the right 3. Up to the right 3. Okay? Up to the right 3. Up to the right 3. Just making sure my eyes didn't deceive me there. Okay, I'm going to make a line through these collinear points. Hope your lines are better than mine. In fact, you can use anything as a straight edge. Straight edge is on point. You can use a credit card, and if you use a credit card, leave it on your desk, and I'll be free to pick it up later. Okay, let's look at this next one, and we'll do it in red. Okay, the y-intercept is 1, so the point is 0, 1, and the slope is -3/2. -3/2 means down 3 to the right 2. Down 3 to the right 2. Down 3 from here. 1, 2, 3 to the right 2. Down 3, 1, down 3, don't make a point there. Down 3, 1, 2, 3 to the right 2. Or, let me just say this, you could write that as 3 over -2, which would be up 3 to the left 2. Up 3, 1, 2, 3 to the left 2. Up 3 to the left 2. Up 3 to the left 2. Anything that makes you happy. Okay, I'm done there. Had enough of points? I've had enough of points right there. Okay, so let's take a look. Notice these are definitely not parallel, because they definitely are intersecting. Okay, now, not only are they intersecting, but they're intersecting in a very special way. If I had a protractor that you could even see, or if I had a protractor where I could measure these angles, all of these angles would be 90 degrees. Since all of the, trust me, Since all of those angles are 90 degrees, we call those lines perpendicular. Perpendicular lines are lines that meet, lines in the same plane that meet at 90 degrees, okay, at 90-degree angles. Okay, so these lines are perpendicular. Now listen, not all intersecting lines are perpendicular. Here's two intersecting lines. They're not perpendicular, okay? So you can be parallel, not have anything in common. You could be not parallel nor perpendicular, just plain intersecting. Or you can be a special pair of intersecting lines which intersect at right angles. I'm going to show you what I mean by that in a second. Okay, so at any rate, let's talk about the slopes of these lines. The slopes of these lines and the tilts of the lines make things happen. Well, notice these slopes. These slopes are not really reciprocals, even though we did change the numerator and denominators, but this one is the opposite sign. So some people call these opposite reciprocals. I call them negative reciprocals. So to summarize, lines that are parallel have the same slopes. Lines that are perpendicular have negative reciprocal slopes. Okay? It means that you flip the numerator and denominator, make the numerator the denominator and the denominator the numerator, and you change the sign. So if this one's going to be plus, one's going to be minus. If you multiply the two of them, 2/3 times -3 over 2, you would get -1. Whereas if you multiplied reciprocals, you get 1. Negative reciprocals is what they're called. Some people call them opposite reciprocals. Before we do some other things, I just want to talk about something. What if that looked like that, if that was positive? If that was positive, these lines wouldn't be parallel because they're not the same. They also would not be perpendicular because they're not negative reciprocals, but they would be intersecting. How do I know they're intersecting? Because they don't have the same slopes. The only lines that don't intersect are parallel lines. So they're not parallel, but they're not that special type of intersecting lines, the lines that intersect at right angles. But they must intersect because they're not parallel. Do perpendicular lines have the same y-intercept? Well, not mine, but some of them could. You could get a pair of perpendicular lines that have the same y-intercept. So that depends on the line. So let's take a second to see what we understand about parallel and perpendicular lines and their slopes by filling in a chart in your workbook. So take a second to do that, and then we'll come back and talk about it. All right, let's just give you some information, which I think you probably know. I just want to make sure you know. Two distinct vertical lines are parallel. What we mean by distinct means different. Okay, so if you have two vertical lines, they have to be parallel. Okay, and then two distinct horizontal lines are parallel. Same, right? Same reasoning. We know that. That makes sense. Okay, and then a horizontal and a vertical line are perpendicular. That's what we make the axis out of, a horizontal and a vertical line. They are perpendicular all the time. They meet at right angles. By the way, if you care, the symbol for parallel is two parallel lines. The symbol for perpendicular is an upside down T. Okay, perpendicular lines, parallel and perpendicular. Okay, let's take a look at this. In this chart, we want to fill in the blanks. And it says, I have a line, its slope is 4/5. We want the slope of the parallel line, and then we want the slope of a line that is perpendicular to that line. Okay, well, we know parallel lines have equal slopes, so if I have a slope of 4/5, the line that is parallel to me will also have a slope of 4/5. Okay? Now, if I have a slope of 4/5, the line that is perpendicular to me has a negative reciprocal slope. So I have to flip the numerator with the denominator and denominator with numerator, and I get 5/4, but I have to change the sign. Negative reciprocal, different sign, flip, change numerators and denominators. Okay, -1/3. The slope of the parallel line will have equal slopes. That's -1/3. The slope of the perpendicular line, I'm going to have to flip that, change the sign. So it's a +3/1 or just plain 3. That's a very steep line, by the way. -6 is a truly steep line. Okay, I'd hate to be on that, but if we think of this as -6/1, which is the same thing as -6, I can answer this question probably easier. Slope of the parallel line is the same, -6. Slope of the perpendicular line, you'd have to flip, change the sign. We get +1/6. And yes, obviously, I have to write the positive. Slope of a parallel line to a line whose slope is 0. And by the way, what kind of line is that? If your slope is 0, we know you're a horizontal line. Okay? The slope of the parallel line is another 0 because horizontal lines are parallel and they have the same slope. Slope of the perpendicular line. Well, there's two ways to do this. One way is to understand that horizontal lines are perpendicular to vertical lines. Okay? So vertical lines have undefined slopes. This is a horizontal line, 0. This is a vertical line, undefined slope. So that's one reason that's undefined. The other reason is I could put 0 over any number and still be 0. When I flip that, the 0's on the bottom, making it undefined. So that's the algebraic reason. Okay? This line has an undefined slope, which makes this a vertical line. Okay? So since it's a vertical line, we want the slope of a parallel line. That's the same. That's easy. But a perpendicular line to a vertical line is a horizontal line, which has a slope of 0. So this is 0. For the same reason, but algebraically, if it's undefined, then 0 is on the bottom. And when I flip it, 0 will be on the top, making the answer 0. So this is just trying to understand the different kinds of slopes and how they kind of connect. All right? So let's take a look at some questions to look at. So if you would fill those answers in your workbook, and then we'll come back and talk about them. All right, let's take a look at those questions in your workbook. You want to fill in always, sometimes, or never, okay? Parallel lines have the same y-intercept. Well, if they have the same y-intercept, it means they have a point in common. That's impossible because they're parallel, so that has to be never, okay? Perpendicular lines have the same y-intercept. Well, we talked a little bit about that. They might. In my example, they did not, but they might. You could have two lines that share the same y-intercept and are still perpendicular, so that's sometimes, okay? And the last one, lines that intersect are sometimes perpendicular. We talked about that also. Perpendicular is a special kind of intersecting lines. They intersect at right angles. There are other kind of intersecting lines. They just don't intersect at right angles. So it's parallel lines never have the same y-intercept. Perpendicular lines sometimes have the same y-intercept, and lines that intersect are sometimes perpendicular, okay? All right, the last thing we want to do today is make sure you understand how this all comes together. So if you would tell us if these lines, and this is in your workbook, if these lines are perpendicular, parallel, or neither. Remember what you need to know. You need to know their slope. Once you know their slope, you should be able to answer this question, okay? So we'll come back and we'll do these together. Okay, let's take a look at this. I know the slope of the first line. I'll call this line A. I'll call this line B. Okay? The slope of A equals 2, right? The coefficient of x. The slope of B equals -2. Well, for them to be parallel, they'd have to be the same slope. They're not the same slope. For them to be perpendicular, they'd have to be negative reciprocals. They are the fact that they are opposites or negative, but they are not reciprocals of each other. One of these would have to be a half, because if you flip 2 over, it'd be 1/2. So this is neither, because they don't have equal slopes nor negative reciprocal slopes. So this is neither. Because, and when you write this in your book, workbook, you need to write down why. They're neither perpendicular nor parallel because they don't have equal slopes and they don't have negative reciprocal slopes. Okay? Let's take a look at number 2. Number 2 is just a little harder because to do number 2, I can't find the slope of this without it being solved. Oh, and I think I wrote this wrong. Let me just fix it up. There should be a y. Okay. I need to solve this for y before I actually do this problem. So let's do this. Y equals, I think I wrote everything wrong. I think this was a negative also. I must have been slipping. It's all good. I got it. Y equals 2/5 x plus 1/5. Okay, so this slope is 2/5. So if I label this A and this B, here's what I got. I got the slope of A is 2/5. I got the slope of B is -5/2. They are opposite signs, and we did use the reciprocal. We did flip the numerator with the denominator. So these are negative reciprocal slopes. So these lines are perpendicular. And it would have helped if I wrote it down correctly the first time. Okay, that's it. That's what you know. Now you know a whole ton about slope. Remember this. To get slopes, the easiest way to get slope is to either count if you have a graph, use the slope formula, or the easiest way to find slope given an equation is to solve it for y. The easiest way to graph is to make a chart. And if you want, you could pick zeros, which means you're getting intercepts. Okay? Or you can use the fact that you have the slope and the y-intercept, and you can count. Use the slope to count. Okay? But the easiest way to graph might be just to make a table every time, so you know what you're doing every time. And that's it. And now you know the slopes of parallel and perpendicular lines, and I think you're good to go.